On this page of notes, we are going to start to look at how we can use evaluating various angles for our trig functions, our special angles on the unit circle. We're going to use that unit circle and those values to learn how to graph sine and cosine today. Specifically though, we are going to graph things without a phase shift. As you'll see at the end of the notes, a phase shift is when we move a graph left or right, and we're not going to do this step today. So before I get into the notes, what you need to do is take a moment to evaluate both sine and cosine for each of the special angles on the unit circle. I already have mine filled out. You can go ahead and pause the video and do each of those evaluating numbers. You'll notice that I have color-coded mine to match the unit circle that we did the other day, so you can see how those match up. So go ahead, pause the video, fill those out, and when you're all done, come on back. Okay, now that you have those filled out, let's take a look at how these values can be useful for us. Up until now, they really just seem like they're numbers on a unit circle and we're just using them for really nothing. The first thing then that we can do on here is find what we would call the quadrant angles. So the ones that are at the ends of the xy axis. So an angle of 0, an angle of pi over 2, an angle of pi, an angle of 3 pi over 2, and of course 2 pi is a coterminal angle. It's exactly the same as 0. So we can identify those values on both sine and cosine because those are going to be significant to us. The next thing that we're going to do is we're going to outline these and separate those out. So what you'll see that I'm going to do here is just to extend these lines a little bit, make these stand out just a little bit on each of them. Because as you are doing this, you can take a look at your unit circle there and look at these values, and we'll notice that at these quadrant angles, all of our numbers are very nice numbers. So you can pause your video as you fill this out. Just going to mark these very quickly. It's kind of the boring part of the video. We could talk about ninjas. I know that you guys like it when I talk about the ninjas. Remember, they're on rooftops, so keep your heads up. Stay safe out there because ninjas are kind of awesome. Okay, so now that I have those marked out, what should begin to stand out to you is that all of these angles right here are in our first quadrant. All of these angles are in our second quadrant. These are all our third quadrant and our fourth quadrant. When we go ahead and we identify those, the same would apply down here for cosine. We can go back to thinking about our all students take calculus. All my sign were positive here, sign was positive here, all of these were negative, and all of these were negative. Same thing down here. All students take calculus. I can see cosine was positive in the first quadrant, it was negative in the second, negative in the third, positive in my fourth. Okay, so those are going to be useful for us. Now, as I said earlier, the reason why we highlighted these 4 quadrant angles is that's where we get 4 nice numbers. So what we're going to do is we're going to use a theta value. We're going to call that our x-axis, and we're going to call our ratio is just going to be our value on the xy axis here, and we're going to notice at those 4 values that the largest value that I get for sine is 1 and the lowest value I get is -1. Now I'm going to divide this piece right here into 4 equal pieces, so I can put a point at each end, find the midpoint. I'm just going to eyeball it, find the midpoint, and of course put a point right there. So we should look like we have some nice evenly spaced numbers. So now this is going to be 0. This is of course our pi over 2, our next key value. Then we have pi, 3 pi over 2, and 2 pi. If we think about rotating in the negative direction, this would be our negative coterminal angle for rotating the negative direction. So this is going to be a negative pi over 2. That's going to be a coterminal angle with 3 pi over 2. Now, we can start plotting these as points. So I plot the point 0, 0. At pi over 2, I'm going to plot the point, I'm going to go up to 1. At pi, I'm going to keep that point right there at 0. At 3 pi over 2, I'm going to go down to negative 1. And at 2 pi, I'm back to 0. Remember, if negative pi over 2 is a coterminal angle for 3 pi over 2, then this should also be a negative 1 right there. Now, if I connect these dots, making these a nice smooth curve, what I will see is, I'm going to put an arrow there. This is going to come up. It's going to reach that high point and come back down. It's going to scoot back down and come back up again. That is what we would call our parent sine curve. And if we think about this at pi over 6 right here, we're about at 1/2, and that should make sense to you. We can kind of think about where the pi over 6, the pi over 4, and the 3 pi over 2 then would land on our curve. Couple parts on this graph that we're going to talk about. An amplitude is the amount that the graph is going to go above or below what I will later call our center line. The center line is this one right here that almost looks like it's splitting our sine graph. Okay, so I can see that I'm about 1 above and 1 below, so my amplitude is 1. The period is how long it takes to complete this cycle. Sine will go forever in every direction because we know these angles could go forever in both directions. So I can see that it creates this little S or snake shape. And if I start at 0, I can see it takes the entire unit circle, or 2 pi, to go from start to finish. As I said, this goes forever in each direction, so my domain is negative infinity to positive infinity. And my range, I can see from both my t-chart and from my graph, only goes as low as -1 and as high as +1, and it is inclusive. We can repeat the same process that we just did down here for the cosine graph. We'll notice that our values are the same, they've just been shifted. So all I need to do on this one is, again, divide up my number line. We're finding that midpoint, midpoint again, and we can even do the 1 in the back. I can see that cosine also only goes as high as 1, only goes as low as -1. Same key values, 0, pi over 2, pi, 3 pi over 2, and 2 pi. Remember, rotating in the negative direction, this point right here is going to be the negative coterminal angle for 3 pi over 2, so it's negative pi over 2. Plot our points this time. This time at 0, I'm going to plot a point at a +1. At pi over 2, now I'm going to be right on that x-axis. At pi, I'm going to be down at -1. At 3 pi, I'm back at the x-axis, and at 2 pi, I'm up top. At negative pi over 2 should be the same as pi over 2, so I need this point right here. So now, just connecting again. Like just connecting my dots, creating a nice smooth curve. Now I'm choosing to only graph certain points because I know what my shape is supposed to look like, but you could certainly graph all of the points and actually connect more dots. Put my arrows on the ends because this is going to go forever in both directions, so there's what we would call our parent sine curve. Again, amplitude is 1 because we have this, we can visualize it as a center line. This is totally a made-up word for me. This is not in a textbook, it's just kind of my made-up visual for that. Amplitude goes 1 above, 1 below. This one also takes 2 pi starting at 0 to complete its cycle. The domain also forever in each direction, so negative infinity to positive infinity. Range only goes as low as -1, as high as +1, and we're inclusive. So those are our 2 parent graphs, and as we turn to the next page, we're going to start to look at how we can stretch those and shift them vertically and change these periods just as we would have done with all of our other graphs. But these mental images of what a cosine curve and a sine curve look like are things that you want to get in your head.